we need to have this handy because we're going to be referring to this as we work forward on the next project. Okay, let's take a look at the basic labor calculations that we're going to need for this project. There we go. I don't know what I did. Anyways, so let's take a look at this. First of all, we're going to identify each project based on, now I've got this already predetermined, but we're going to look at each project and kind of get a sense of what it's going to take and how you take a look at it. Sorry, my sheet is floating around here. Okay, fence posts. Now, again, based on experience, based on timing, based on this crew, it's been determined that the fence post is best installed. The most efficient installation is when you have 2 people involved. So for fence posts, we've determined that it takes 2 people. Now, there's a lot of things that could have determined that. What kind of auger are you using to install the post? Maybe if it's a hand auger, and I used to, when I was studying architecture, our engineer asked, how many of you, if you went out on the site, would use a 2-person hand auger? And a number of us raised our hands, and he goes, I'd never hire you guys. And we're like, why? Because that's the most dangerous of equipment that there is. So somebody's going to get hurt, and therefore, if you're going to use it, I don't want to hire you. That's just a side note. So to put in a fence post, whether it's a 2-person hand auger or a piece of equipment, you need somebody on the ground monitoring the depth and making sure that the auger is cleaned off while somebody's operating the equipment. So regardless, we're going to go with 2 people in that particular sense. Now, what about the fence sections? What do you think? Well, typically a fence section will require a 2-person manipulation. And again, it could be a number of different reasons. Maybe the weight. I mean, there are ways of installing it. I've put in fence sections by myself before. It's been very cumbersome. But from an efficiency standpoint, 2 people is probably the best way to be able to do it. What about the gate? Arguably, 1 person could install it, but it's far easier with 2. And again, there's a bit of holding this in place and holding that in place and making sure all of that is, in place for that position or to install it properly. What about brick? So brick is basically, there's a pile that's at the front of the property that you have to load up into a wheelbarrow and then place it in the location. Well, 1 person can do that. I'm sure all of you have had mulch delivered or have done anything of that nature, and so we're looking at the minimum number of people. And for brick, I think the installation of the brick, you can definitely manage with 1 person. It's not any more efficient with 2. It just takes half the time, right? Fertilizer. Once again, 1 person would be fine to install fertilizer. What about the crushed rock? The crushed rock is like the brick. What about edging? Again, what's the minimum requirement? Yeah, you can get away with 1 person to do the edging. And then once again with the shrubs, all you need is 1 individual to install a shrub. Obviously, 3 individuals installing a shrub will take 1/3 of the time, hopefully. So, again, what we're doing is we're going to eventually calculate the manual hours that are required. So when we're looking at time, the element of time is if 2 people are working on it, how long would it take to install a fence post? Each one. And therefore, again, helping us to determine the labor cost. I'm typing and talking at the same time, so if it seems broken up, it's just because I'm trying to do 2 things at once, and that's not a great skill I have. Okay. For this purpose, we're going to say, based on historical data, based on experience of the estimator and the crew chief, it takes approximately 30 minutes each to put in a fence post. Well, how do they determine that? So, in fact, over time, there's more to it than that, though. What happens is this. Every project that a crew chief does, and they develop the schedule, at the end of the day or at the end of the period of installing something, they should be indicating the time. How long did it take 2 people, 3 people, whatever the number is associated with the project, to do that? So if somebody's installed, a crew has installed, let's say, 60 fence posts. and it's taken X number of hours for so many people to do it, it's pretty easy to break it down to say it should be this. And that's how they determine it. Now, there's more to it than that. I know we're not overcomplicated, but there is. For instance, where I live, you go 2 feet down, you hit rocks. So now you also have to have a jackhammer on site. And that jackhammer could take an extra 30 minutes for a single hole to break up the rocks to pull it out. So there's more to it than just what we're talking about. But for now, this is what we're going to be dealing with. So we've got the fence post. So the fence post is dig the hole, place the fence or post, center it, level it, pour the concrete, and have it set. Not the time that it takes the concrete to set, but the manual labor portion of installing that post. From start, digging the hole, to finish, having it set in concrete. Okay? That's what the estimation is coming like. Now, you may agree or not agree with it, but that's what we're going to be going with in this particular case. What about the fence sections? So this is after the posts have been set, installed, and they're ready to be put in. The sections are ready to be put in. We're going to say about 20 minutes each. So that means the sections are, well, these sections, we haven't talked about, are they pre-made? Are they not pre-made? Yeah, let's make certain assumptions. Let's assume to some extent that there is a portion of it that's pre-made. And therefore, for 2 people to place it in place, level it, put in the brackets to help install it, screw it in place. And again, we don't know how complicated this section is. Maybe it has some mesh or, lattice work above it. So yeah, the numbers are basically from the project, but I'm giving you the timelines for now. So we're going to get to that. We're going to get to how many there are in the calculation portion of it. Okay, so you're just one step ahead at this point, but no big problem, no big deal. What about the gate? 2-person. I don't know how many of you installed a gate. Some of these gates can be really challenging. So what about this gate? I'm going to be very, very generous with the gate because the gate not only requires installation, but leveling. Maybe there's a requirement for the latch system. I can't spell, sorry. Maybe there's all sorts of different requirements for the gate. So I've assigned 2 hours to that gate. So depending on, let's say it's a self-closing gate, you've got the hinges have to be installed, the gate has to be placed in the correct location, the latch has to be installed, the release has to be installed. I'm going to say 2 people, 2 hours to get the gate done. It's generous, but that's okay. For the purposes of this, that's what we're going with. Okay. What about the next section here? Bricks, the installation of the bricks. Now, what we've done in here is identified 1 person. But notice how the bricks, when we did the calculation, was based on square feet. So based on bricks and experience, I'm going to come up with this number. Let's see, per square feet. Okay, square feet. That's that. All right. I'm going to come up with this, that it's going to take 1 person 2 hours for every 100 square feet of brick installation. Okay? And again, it's a number I've come up with. It's not important that it's there. I've got 1 person and 2 hours per 100. That should really be, I made a mistake here. It should be 2 people. Sorry. That's a determination I made. Okay? So what about the next step in here? Fertilizer. How long should it take to place that fertilizer on the entire lawn? So we've got just a basic spreader. The lawn isn't all that big, so I've applied 1 hour to do that. What about the crushed rocks? So the bricks require a bit more attention. The crushed rocks, not so much. So we're going to put for this one 1 hour per square foot. Okay, question. No. So when you're putting on fertilizer, I mean, the lawn looks really big, but really you're pouring it into just a spreader and then walking around the lawn. So it shouldn't take more than an hour to do. We also don't know whether this is something that, requires fertilizer mixing or anything like that. Sometimes the spreader will have just a basic gauge that allows us to identify how heavy the spreading of the fertilizer is, and it doesn't take long to do it. So for this purpose, it's fine. 1 hour to install fertilizer. It shouldn't take more than that for this case. What about the edging? Edging. We're going to go with, let's see in here. Edging is going to take, and again, this was all sort of predetermined, 1 hour for every 50 linear feet. Now, that's something that is a calculation that can be, done over and over again. And it's based on experience. How long does that particular edging take? And then the last one, shrubs. So when you think about shrubs as an individual, how long does it take you to install shrubs? So considering, again, soil conditions and everything like that, we're going to say 1 hour for every 10 shrubs. Now, you may disagree with that. You may agree with it. It's not as important. It's a matter of understanding how we break this down. So this is a project breakdown. So for fence posts, 30 minutes each. But that's with 2 people installing it. For fence sections, 20 minutes each. 2 people installing it, and so on. Fertilizer is only 1 hour for 1 person. Crushed rock, 1 hour per 100 square feet per person. So you may have 3 people working with 3 wheelbarrows to do this, and therefore, the calculation will be slightly different, but in fact, the numbers stay the same. So that's not as important. So let's take a look at the actual calculation. And please, by all means, verify this whenever I'm doing work on here to make sure my calculations are right, because I'm trying to look at and do in multiple screens at the same time. So I'm looking at, in this particular case, the fence posts. We've got 40 pieces. I can't remember which estimate that was. And we're going to be going with 30 minutes each. That will be times 0.05 hours. And there's going to be 2 people involved. So times 2p. Okay. So there's our calculation. Okay. So number of pieces, 40, or 40 posts. How long? 30 minutes each post. 2 people. So what does that mean? It means simply 40 times, 0.05 times 2. Okay, there's our calculation. And that means it equals, and I'll answer your question in just a second, equals what? 40 times 0.5, which is 20 times 2, equals 40. So what does that mean? That means the total number of manual labor hours here is 40. So this is the crew chief working with the estimator, identifying, don't we need to break apart these two? Okay, yeah, we're going to get to that. You'll see how that will come into place. Right now, we're just determining the total number of hours. That's all that we're doing. Okay, but good question. It'll come up in just a second. So the next section of this, fence sections. What are they? There's 38 sections, and that will be times 20 minutes per section. Now, how do we show that as a calculation? Well, I'm going to do it here, and hopefully this will make sense. And times 2 people. Okay, so what am I doing? What we're trying to do is determine the number of hours. Okay? And so if we take 20 minutes and divide it by 60, that's 60 minutes, that's 1/3 times 2. Okay? let's see if this makes sense to us in the math equation portion of it. So I'm going to do that right now here. So if I do this, it's 38 times 20 divided by 60. Why 20 divided by 60? Well, we're determining how many hours each thing will take us. And therefore, 20 minutes divided by 60, which gives us a third, or a third of an hour. And that's how we'll come up with that. Okay, so I got this. Oops. That looks right? Yep. Okay. Let me make this bigger, just so that we can see this one. That better? So that one is 40. So when we look at this one, down here, and I'm doing copy, paste, and editing it. I'm trying to make this as neat as possible, so it makes sense. There we go, 26. And we go through each one of these calculations to determine it. Okay, this is what I'd like you to do. Looking at it this way, go through this and see if you can figure out the rest of it. Okay? See if you can determine the rest of the numbers. I'll be doing it at the same time, just so that we have it here. But I'd like you to try to do this estimating process to determine what are the total manual hours that are required to do this project. Are we okay with that? Good question. So, 450, 754, 104, and 300 shrubs. Okay, let me write that in here, because that's a good question in here. So for the gate, you don't need square footage. For the brick is 450 SF. For the crushed rock, it's 754. And for the edging, it's 104. And for the shrubs, it's 300. Okay? Gates. Two people. No, there's only one gate. Oh, hold on. 1 times 2 hours times 2 people. 1 times 2, 4. No, there's only one gate. That's okay. Okay, so you guys go ahead. I'm going to put the answers here, but I want to see if you can come up with the answers yourself so that you understand the process, because this will be asked of you at a later time. So what we've been able to determine here is what? Well, the total hours, and again, estimating. The total hours, in this particular case, requires 128.5 divided by 3 people is 42.83 hours per person. So for a crew of 3 people, this project is about how long? Well, it's approximately equal to what? 1 week. Okay? And that's the way we're looking at it. So right away, at this point, the estimator or the scheduler can plot this into the schedule and say, this is how long it's going to take. The estimator, or sorry, the crew chief can take this information and says, okay, this is what I'm allotted. This is what I'm going to try to maintain as a schedule to make sure this works. But now what we're going to do is look at, well, how much does this cost? How are we going to determine the cost of this? So to estimate the labor, what are we going to do with this information? Oh, I keep typing on the wrong keyboard. Sorry about that. To estimate the labor, how are we going to determine that? Well, essentially, we've already determined that. Why? Because we know that Leslie is at 35 bucks an hour, right? And we're estimating that each person is going to be taking approximately the same time, which is about 43 hours. That equals what? Well, this should be about 1505. I'm just going to do this one at a time here. So that's Leslie. I'm going to duplicate this here. I'm just going to fix some of the information in here. And Stan is at 25 bucks an hour. And 43 hours is, how much is that? Well, that's 1075. Okay. That's here. Let me just move that. And who else do we have here? We have Veronica. I need some more room here, so I'm kind of squishing this in here. Not Stan, but Veronica is at $25 an hour. So what's our estimated labor costs? Well, we just add those together, right? So in this particular project, our estimated labor cost here is $3,655. Oh, I used the wrong sign here. Hold on. Is $3,655 for the project. There's our budget, right? There's our budget. And that's the budget that the estimator is going to go with based on the information that was provided with the crew chief. And therefore, that's what we're going to go with. So all the 2P tasks have Leslie in them. Yes. So we're going to be looking at that momentarily because this now will require some challenges. And that may, as you've already pointed out, change the numbers. But this is what we've got to try to do. Because we can't have, a person just sitting around. So those one-person tasks are really important. But we also have to, make sure that the individual that has to be involved in every two-person task is scheduled accordingly. Because, not only are they supervising the job, but in this particular case, it may be a young crew, and therefore requires to actually teach along the way. So Leslie is the crew chief. I'll just put that in here, just so we're sure of this. And you can call it whatever you want, crew chief, lead hand, site supervisor, whatever you want to call it. That's really what we're dealing with. But now the estimator can take that number and complete their estimation. On a significant project where the numbers and the budgets are tight, this may happen very early on in order to give a price, a quotation to a client. And in a lot of cases, it's based on their experience with previous projects, breaking it down this way. And also keeping track of the project to see whether it did take 18 hours to install the brick. Maybe it was only 15. But the gate took 6 hours, not 4. And therefore, those are the numbers that get compiled. Like a lot of this is just data management, right? Trying to compile this in order to make sure that it works right. So, what do we need to know? Well, the next thing we're going to do is we're going to consider what's called a critical path. And a critical path helps us to basically look at a project and determine the order of operations. So what do we know? And I'm going to just use the task numbers in this particular case. We have the number 1, which is fence posts. That has to be installed when? Well, the fence post must be installed before what? The fence sections, right? So what we can do in this particular case, and I'm going to crudely draw this. I wish I had a bit more of a sophisticated software to do this. 1 has to happen before 2. What about task 3? Task 3 are the gates. Well, task 3, right, has to happen when? Well, it also has to happen after 1 occurs. And this is how we would show it. Does it matter whether we do 2 or 3 first? No. You can go from 1 to 3 or from 1 to 2. And that's the requirement of it. Okay. What about everything else? So I'm going to draw the critical path here based on discussions that we've had on when things are going to occur. Now notice I'm going to just change things up a bit because this gives the impression that 2, 3, and 6 are happening at the same time. They don't have to happen at the same time because this is not a chart identifying a timeline. It's a chart that's identifying a critical path. What's actually happening. So in this particular case, the edging is going to be installed before the crushed rock, which is going to be installed before the brick. And that was a determination that was made. What about 8, shrubs? Well, shrubs are independent. Nothing has to happen before them or after them. But what do we know about fertilizer? When did we say the fertilizer has to occur? Fertilizer has to occur when? After everything has happened. So basically, what we're doing is this. That has to happen and be finished before that. That has to happen and be finished before that. And so does everything else. So number 5, sorry, I drew this really poorly. Again, I'm trying to estimate here. Estimate, play on words, right? I'm trying to estimate that there. It won't let me draw that. Okay. And if I erase it, I erase the whole thing. So I'm going to do it this way. And that's just indicating that 1 occurs before 2, occurs before 5. 1 occurs before 3, occurs before 5. 7 occurs before 6, occurs before 4, occurs before 5. And 8 occurs before 5. That's what that's indicating. This is how we start developing the order of the tasks listed. So these are basically prerequisites. What has to happen in what order of things? Yeah, so we're using that as an underlayment. It really is granular A, okay? So what you're looking at is you're putting in the edge, you're putting in the granular, and then you're putting... Now, there could be an argument. There's lots of arguments, right? The argument could be that you're putting in the granular and then the edging. In this particular case, they want to put the edging in first, that's all. There's no absolute right or wrong. It's a matter of each crew works maybe differently. And that's why it's very important, the communication level of who's involved in the project, how are they going to address the project and what needs to be done. No. So the fertilizer is the last. So the idea behind all this is simply this. You want all the shrubs in. The fertilizer is only for the sod. You want all the shrubs in so nobody's walking over top of the grass, the sod, after the fertilizer's been laid on. Yeah, okay. So what we're doing is basically we're making sure that the fertilizer is placed. I mean, the argument could be that, okay, the fertilizer is meant for the grass and the shrubs. It doesn't matter. It's just the way this particular project is. This is how we're doing it in order to help us with the next stages. That's all. Okay? Now remember, I mean, we could have had a different fertilizer for the shrubs. We could have had a different fertilizer for the sod. So once the shrubs are all in, you want to fertilize the shrubs and then the sod. Typically, you want to fertilize the sod last, so nobody's walking over top of it, right? After it's been fertilized, and then all you're doing is spraying it down with a hose, and hopefully it rains in the next few days. That's all. So it doesn't matter. Okay. This chart is simply identifying the sequence of events. It's not giving you a timeline. It's not saying 2, 3 is happening between 6 and 4. Nothing like that. Okay? The next step that we're going to be putting all this into is just that. Understanding time and how time will all happen. No, but it's an order of events. That's all it is an order of events. 5 does not need 7, 6, and 4, but 5 cannot happen until 7, 6, and 4 occur. So that's the different thought process that's behind here. And hopefully it will make more sense as we go through the next stages. Anybody else, any questions? Okay. That's why the project scope is very important. That's why defining the project and what the intentions are very important. That's why breaking it all down into its complexity is very important. So all of those particular questions that are coming up now could be answered and therefore have definitely an effect on the charts, on the tables that we're doing. But we're looking at this as a generality, just as a simple project for now.